Hi guys, it's Miss Elkins. So sorry I can't be there with you today to teach this lesson. I hope you get what you need out of these notes, and of course if you have questions when I come back, I'll be happy to answer the questions for you. Today we're going to learn about scientific notation. And scientific notation is just a way to make it easier to write extremely large or extremely small numbers by allowing us to leave off zeros. Okay? The first step of scientific notation is to place a decimal after the first non-zero number, the first one. Okay? Second step, count how many places it takes to get back to the original decimal. The third step is to write the number in scientific notation. Here's a key. Big numbers have positive exponents and small numbers have negative exponents. And you can still have a positive number or a negative number in scientific notation. That doesn't change anything. Okay, so let's look at the first example on your notes, and all you have to do is read through the notes. At this point you should have notes in your hand and you should be following along by the paper notes that you have been given by the sub. Okay, if you don't have the paper notes in your hand, go stop now, stop the recording, get the notes, and come back and start over. All right, so first example is to write the following number in scientific notation. There's so many zeros after that number, I'm not even sure how to say that number, but it's, I don't know, 8,578 badillion, and that's the number. And you can see there are a lot of zeros after that last 8, which makes it a really, really large number. So step 1, place a decimal after the first non-zero number. 8, the first 8, is the first non-zero number, so it should have a decimal after it. So you can see that's been done for you on the notes. It says 8.578 and then a bunch of zeros after it. So that's where we move the decimal to. Now it says count, step 2, count how many places it takes to get back to the original decimal. There's not a decimal in the original number, but when there's not a decimal, you know it's implied there at the very end of the number. So we count how many places it is from here to the very end of that number. So we'll count, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We had to move that decimal 15 places to the right. Now that we know how far we had to move the decimal, and we've replaced it and put it after the first non-zero number, which was the 8, we're going to rewrite that in scientific notation. When you're writing scientific notation, there's always a times 10 after the decimal number. In this case, there's going to be an exponent with the 10 of 15, because that's how many places it took us to go to the right of the decimal. So the new number in scientific notation is 8.578, and then we get to drop all the zeros times 10 to the 15 powers, because it took 15 places to the right of the original decimal. If you want to stop now and try something in your calculator, this might help you understand why scientific notation actually works. If you take 8.578 and you multiply it times 10 to the first power, it will move the decimal one place to the right, and it'll be 85.78. If you multiply 8.578 times 10 to the second power, which is, by the way, 100, it will move the decimal 2 places to the right. So it becomes 857.8. And that pattern is going to keep on repeating. This is why scientific notation works. If you multiply 8.578 times 10 to the third power. That will move the decimal place 3 places to the right. So then your number becomes 8,578, and the decimal's now at the end of all those digits. It keeps on going. If I multiply 8.578 times 10 to the fourth power, it will move the decimal 4 places to the right, and it becomes 85,780. Notice it moved 1, 2, 3, 4. Oops, I miscounted, sorry. It moved that decimal 4 places to the right, just 4 places, not 5. Okay, and again, if you multiply 8.578 times 10 to the fifth power, that'll move the decimal 5 places to the right, and it becomes this number, because we have to start adding zeros when we add decimals because there's nothing there. Okay, so you can see that every time you multiply a number, every time you multiply a number, little glitch in my system there, sorry. Every time you multiply a number times 10 to a power, that exponent tells you how many places you're going to move that decimal. Okay, so here we moved it 5 places. For this number, 8.578 times 10 to the 15th power, we will move that decimal. I'll have to move over here a little bit. 8.578 times 10 to the 15th power means we have to take this decimal and move it 15 places, which will give us our original number, which was, I'm not even sure how to read it, 8,578 badillion, blah, 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 lots and lots of zeros. So that's how scientific notation works. It allows you to write a number with a bunch of zeros after it in a smaller form, because you can see this number is a lot smaller than that number. Okay, I hope this is starting to make sense with you, but we're still going to do some examples. All right, so turn your paper over to the next example. It says write the following number in scientific notation. This is totally different from that first number, which was 8 gazillion. This one is just a very, very small decimal number. As you can see, there's a lot of zeros after that decimal before you even get to an actual number. So we have how many decimal places after the decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimal places. So that's like 35 trillionths. It's a very, very tiny, tiny, small number. Okay, so your steps are still the same. You're going to look for the first actual number that's not 0. The first actual number that's not 0 in this case is 3. 3 is the non-zero number, so it should have a decimal after it. So we'll move the decimal from here all the way to here. Okay. So now count how many places it takes to get back to the original decimal. Well, from here to here, there's 9 places. You can see. Well, I'll count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. We had to move it behind the 3, which made it move 9 decimal places. My original number, very, very small decimal. I move the decimal 9 places to the right, and I get this number, 3.5. That means I can drop all those zeros times 10 to the negative 9th power. See the difference? When you have a really, really small number, the exponent's going to be negative. So when you rewrite 0.0000000035 in scientific notation, it just becomes 3.5 times 10 to the negative 9th power. The reason? Because you moved it 9 places to the left from the original number. Okay? So, very, very small number, negative exponent. Very, very large number, positive exponent. Here's another example. Hopefully, it'll help you understand better. Write the following number in scientific notation. What I want you to think about, is this a very large number or is this a very small number? If it's a very large number, the exponent with the 10 is going to be positive. If it were a very, very small number, the exponent would be negative because it's a very, very small number. So step 1 is place a decimal after the first non-zero number. 1 is the first non-zero number, so that's where you're going to move the decimal to. The original decimal isn't actually shown, but it would be here at the end of the number. So we're moving from here all the way to here. We need to count how many places it takes to get from that original decimal to the new one after the 1. It's 10 places. We had to move the decimal 10 places. You can count like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, wow, that's not 10 places, is it? That's 9 places. Something is amiss here. We had to move it 9 places. That's a mistype on these notes, so sorry for that. Okay, so now that we know we moved it 9 places, and I counted, I'm double checking just to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places. That means it's a very big number. I'm going to write it as 1.025. You can't leave out zeros if they're in between numbers, but we can leave out all of these zeros because we moved our decimal right here. The final answer here, 1.025 times 10 to the 9th power, not to the 10th power. There was a big mistake made there, or somebody forgot to type in a 0, I suppose. All right, so we only had to move it 9 places, not 10. Okay, so your exponent is always going to be the number of places that you move the decimal. So you don't have to guess what the exponent should be. You just count numbers. How far did you move the decimal to make it a number between 1 and 10? And I want you to write that down here as part of step 1. Step 1 says put a decimal after the first non-zero number. The way I like to say it is to move the decimal, write this down, move the decimal until you have a number between 1 and 10. And I'll show you what that means. If I gave you this number, I'm making something up, but please write this down. 1, 2, 3, 0, 0, 0, comma, 0, 0, 0. Okay, I want to make that number a number between 1 and 10. The original decimal is here. If I move it 1 place, that's not a number between 1 and 10. If I move it 2 places, that's still not a number between 1 and 10. If I move it 3 places, it's still too big. If I move it 4 places, it's still not a number between 1 and 10. If I move the decimal 5 places, or 6 places, or even 7 places, that's not a number between 1 and 10. I need to make it a number between 1 and 10, which means I'll put it right after that first number, which is 1. And now I'm going to change my number to 1.23 times 10. It's always times 10 to the power that I moved the decimal. Now this is a really big number, so the exponent's going to be positive. How many places did I move it? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it'll be 10 to the 8th power. So these directions tell you to make the first non-zero number. I personally prefer to say to move the decimal until you have a number between 1 and 10, because that makes more sense to me. But both ways of saying it are correct. So whatever makes more sense to you is, of course, fine with me. All right, let's do some more examples. On the next page, these are just done for you. So these are the part where you can think of this as your textbook. Look back at this over and over again until you're comfortable with doing this. Please keep your notes in your folder so you'll have access to them while you're doing your homework, and you'll be able to have something to go by, something to look back at. Okay, on the next page, the next example is write the following number in scientific notation. As you can see, it's both a negative number and a really, really small decimal. So our scientific notation number is going to be negative, and our exponent is going to be negative. So first things first, place a decimal after the first non-zero number. I like to say make it a number between 1 and 10. So if you put a decimal right there, right here, then it becomes a number between 1 and 10, or 1 is the first non-zero number, so you put a decimal after it. However that makes sense to you. So we move the decimal all the way from here to here. All right, and it says count how many places it takes to get back to the original decimal. Well, how many places did you have to move it? I'm going to go up here to this one and count because it still has the decimal, and these for some reason are missing it. So I went from here all the way to here. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I moved it 12 places to the left to make my number between 1 and 10. And so this is going to be my scientific notation. Negative, remember the number was negative, 1.872. We always leave all the whole numbers there. We can drop the zeros, but we don't drop any digits other than 0. And then times 10, because it's always times 10, to the negative 12 power. That's how many places we moved. It's a really, really small number, so we moved it backwards. So it's a negative exponent. So leave off the zeros that are in a row. Do not leave off zeros that are in between numbers. And just follow this process each time. All right. Now, let's do some examples that are done for us. And we'll start with this first one. I believe that is, 50,874,000,000. There's no decimal, so I put one on the end. I have to move it, and I'm going to count by threes. Well, maybe not. I'm going to move backwards 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. I got to move backwards 10 places before I can get a number between 1 and 10. The number between 1 and 10 is going to be 5.0874. I can't drop that 0, but I can drop all these zeros because they don't need to be there anymore. So my decimal, 5.0874 times 10, because it's always times 10, to the, how many places did I move my decimal? 3, 6, 9, 10. So 10 is my exponent. Move the decimal 10 places, use an exponent of 10. I'm hoping this is starting to make sense to you. All right, the next question is a negative number, so that doesn't change anything, but it's also a very small number, which means we have to move the decimal to the right to get a number between 1 and 10. So the decimal's here. I've got to move it 1, 2, 3, 4 to get to a whole number between 1 and 10. So here we go. It's 4.51, because we're going to drop all the zeros before it, times 10 to the negative. How many places did we move the decimal? 1, 2, 3, 4. To the negative 4th power. Negative 4.51 to the negative 4 power. All right. The next question is also a negative number, so my answer is going to be a negative number, but it's a big number, so my exponent will be positive. So I'm going to put negative here so I don't forget that this is a negative number. To make this a number between 1 and 10, I need to move my decimal from the very end, after that last 0, to the in between the 1 and the 9. So my decimal for this will be 1.9 times 10, always to times 10. And let's see, how many places did we move the decimal? 1, 2, 3, 4, 5, 6, 7 places. So we moved it backwards 7 places. So we moved it backwards 7 places, so my exponent is going to be positive 7. So negative 1.9 times 10 to the positive 7 power. Notice how the really small numbers have an exponent that is negative, and the really big numbers have an exponent that's positive. That's never going to change. So we got another number here. It's a really small number. What do you think the exponent is going to be? Is it going to be positive or is it going to be negative? That's right, it's going to be negative. So I need to make this a number between 1 and 10. I'm going to move the decimal right here. So I'm going from here to here. So I'm going to have a number 2.305. You can't drop any digits except zeros at the end or at the beginning. And times 10 to the negative some power. Let's see how many negative powers it's going to be. How many places did I move the decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9 to the negative 9 power. And the last example is a really big number, so I know that my exponent is going to be positive. I need to make this a number between 1 and 0. I'll put in a decimal right after that first one, and it becomes 1.0356. I can't caution you enough, don't drop numbers, only drop zeros after the last number. Okay, so let's go back and count what my exponent is going to be. How many times did I move the decimal? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a positive 9 for my exponent. And that, my friends, is scientific notation. At this point, you should be getting your homework to try for tomorrow. The first 15 questions are all writing numbers in scientific notation. Be careful that you make the negative exponent if it's a really small number, or a positive exponent if it's a really large number. And also be sure that if the number starts out negative, you don't lose that negative sign, because that doesn't change. And then the last few questions are a review of number types and then a couple of true-false statements. Anything you have questions on, you just go ahead and try your best, do your best. And then Tuesday morning, hopefully I'll be back and I'll be able to answer questions for you. If I'm not back on Tuesday, we'll keep going like this until I can come back and help you. Hopefully I'll see you Tuesday. Have a great day, and I'm out.